And we're back. Thanks for coming back to the introduction of Hyper-V, our jumpstart today. Again, I'm Jeff Woolsey, and this is Symon Perriman. We've been talking about a variety of different topics. We've gone through the introduction, the infrastructure, networking. Now we're off to Hyper-V storage. So a couple of things to think about when it comes to storage and kind of the agenda for this discussion. A bunch of different storage considerations, as well as how to create virtual disks, the different types of options out there, iSCSI, virtual fiber channel, MPIO, ODX, a whole bunch of new capabilities that we've added to the core when it comes to both Windows Server, Hyper-V, and including the new Windows Server 2012 file server. There's a whole bunch of greatness happening on there, so we definitely want to get to that as well. So let's talk about some of your input again on storage, because again, that's what helped us drive the decisions we made in developing Server 2012. So one thing that kept coming up over and over again was, hey, please leverage my storage array capabilities. So whether I purchased a small, medium, or a high-end enterprise, massive SAN, do whatever you can to leverage the capabilities built in there. I want to make sure that you're leveraging that storage and maximizing that investment. Also, I want to provide native access to my SANs from virtual machines. So one of the threads that we've kind of been having throughout this discussion is the ability to provide scale-up, large-scale, massive applications, massive workloads, move those into virtual machines without any sort of compromises. Well, again, a large chunk of these applications tend to be attached to a SAN, perhaps Fibre Channel, iSCSI, and you want to be able to provide that native access within the virtual machines without any trade-offs. Please help me reduce the cost of storage. If you've ever looked at your infrastructure and if you've ever looked at what your costs are, most people realize very quickly that storage is actually usually the majority of your infrastructure costs, or it's at least a very significant part of your infrastructure costs. So if there are ways that you can help me reduce the cost, use my investment, maximize it both from a resource usage as well as lowering the cost and making it easier to manage, that would be great as well. Finally, big data.
So quick question.
Yes.
Do we require a SAN for Hyper-V?
Oh, great question. Absolutely not. We've never required a SAN. It depends on what the features are and what are the requirements of the deployment you're talking about. So, for example, if you're going into a production environment, you're going to want high availability. You're going to want clustering. I mean, come on, who's going to deploy a production workload without having a high availability solution in place? So if that's the case, then having a SAN has been a requirement in the past. Not necessarily anymore in Server 2012, and we'll talk about that, but big spoiler alert, the new Server 2012 file server is an awesome way to provide you shared storage and not requiring a SAN to do it. Finally, big data. So this is something we've been watching, tracking very closely. Industry analysts everywhere are looking at the amount of data that we are consuming. I mean, we have more devices than ever before. We've got phones, we've got laptops, we've got tablets, we've got mail, we've got data everywhere. We've got it's just coming out of our ears, and we've got better and better tools for doing analytics. But now that we've got all of this data, now all of a sudden virtual machines have been running into brick walls. For example, virtual disks, whether it's insert virtualization platform here, have had limits, 2 terabytes per virtual disk. And customers have told us they've run into that limit multiple times, and they really would like us to take this to the next generation, and they don't want the virtualization storage layer to be an inhibitor to big data. Key thing to remember, I touched on this earlier, but this is absolutely a bedrock principle, is that storage performance is almost always the virtualization bottleneck. Very often someone will ask me, hey, should I get the 2 gigahertz processor that's got 4 cores, or should I get the 2.4 gigahertz processor that's got 4 cores? Honestly, CPU has not been our bottleneck for a long, long time. It's really I/O, and it's especially storage. The difference between having a single disk, between multiple disks, the type of disk, the amount of IOPS that I can deliver, as well as the really industry-changing, world-changing events happening with SSD are dramatically changing the performance profiles for storage. Here's something to remember. Keep in mind that if you've got a 15K SAS drive, on average, that disk is going to deliver you anywhere between 150 to 200 IOPS per disk, okay? On average, 150 to 200 IOPS. If you've got a SQL workload that needs 50,000 IOPS, 100,000 IOPS, you need a whole bunch of disks. And really, it's really that straightforward. It's math, folks. Well, now, don't just think about that SQL, but guess what? You've got other VMs that you want to run, and you're running it on that same infrastructure. So generally what we find is people tend to under-provision their storage, and then when there's a problem, blame the virtualization layer. So it's really important that you understand that storage performance is almost always the virtualization bottleneck, and there's a bunch of things that we can do to help that out, and we'll talk about that. Certainly implement storage solutions with multiple hard drives to distribute disk I/O. When we look at the storage industry, one of the things that has always kind of, I feel like I've been waiting for this for a long time now, is I was going through my garage a few months ago. I found in my garage my old Atari ST 20 megabyte hard disk. Ooh. Size of a shoebox. Nice. Just, come on, how awesome is that? And I'll never forget, I bought that thing for like $700. I never forget bringing that home and my mom screaming at me in Spanish very loudly, "What are you doing? Why did you spend $700 on a box with a little blinky light on that?" And she could not understand this. And the thing that is always, but as I picked that up in my garage, I was very struck by the fact that storage has not changed in a very, very long time. In fact, you can go back into the 70s and 60s and back into the 50s, and if you look at hard disk technology, we've been very, very much limited by the fact that there's a spinning disk and there's a little read-write head that goes across the platter. Okay, that's what's been limiting us to a very big, for a very long time, for decades. And certainly the platters have gotten faster. We put more read-write heads on there. We've improved caching algorithms. We've done a whole bunch there, but we're still limited by the fact there's a read-write head that has to go across there. SSD is changing this, folks. SSD is dramatically changing the economics and the price performance of storage. It's huge what's going on here. Because think about this. Remember the comment I made earlier. 15K SAS disk is going to get you about 150 to 200 IOPS per disk. So if I have that big scale-up workload that I want to run, 50, 100,000 IOPS, my storage vendor is going to be thrilled because I'm going to bring in lots and lots of racks of disks. And there's a lot more reasons than just IOPS, but IOPS is the big reason. Well, now I can go out and I can buy an SSD for about $200 that gives me 25,000 IOPS. On a single SSD. It's what I'm running in my laptop. I spent $250 for, and I'm getting ridiculous performance. So it cannot be overstated that you need to think about what's going on in storage, understand that storage is going to be your bottleneck, and really try and make sure that you think about long-term, what are my strategies for storage going forward, and how am I going to make sure that SSD is a part of that? So certainly talk about that. And also, consider deploying centralized storage. Now, you asked me earlier, Simon, about, are SANs required? In the past, SANs have been required if you wanted it for failover clustering, if you wanted to do it live migration. With Server 2012, you can now do it with the file server. And with huge advancements, we've made an SMB3. So you can get high availability, you can get mobility by using the file server. And you can also get live migration mobility without any shared storage as well. So we'll talk about that as well. So when it comes to storage, we've got lots of different options. And I always get this question, Jeff, what should I use? Should I use direct attach? Should I use iSCSI? Should I use Fibre Channel? Should I use, what should I be using? Please tell me. And it really comes down to what are the requirements? What are the performance characteristics? What type of environment is this? Is this test dev? I can tell you right now, in my office, I got a couple machines, single machines. Again, these are desktop class machines, but guess what? You put in a couple SSDs in there, it's amazing the performance I'm getting there. Now, again, this is test dev, so I don't need failover clustering. That's not a big deal. Is this a production environment where I'm running production workloads and failover clustering is something you absolutely want to deploy? Then yes, and you're going to want to figure out what is that centralized storage. It can absolutely be a SAN, it can be iSCSI, it can be Fibre Channel, or it could be shared SAS, or it could be, now with Server 2012, it can be a file server. So there's a lot of different options, and the reason why we give you those options is because it's going to depend on how you deploy. If this is a branch office, maybe 2 servers and a file server right in the middle is all you need. If I'm in a data center and I'm running something that has, and I already have a SAN, then maybe you want to take advantage of that and take advantage of those capabilities that you already have. So really, there's a lot of different options based on your deployment needs.
So I have a question here. You know, we have these students that are excited. They've already got the server hardware. They now know that they can get the free Hyper-V server as the OS. What's the cheapest storage solution that they can use that they may already have today to actually just build up a test environment? No high performance, just cheap. Let's get it functional.
Sure. So if you're using Server 2012, you could take advantage of the fact that we have iSCSI built into Server 2012. You could take advantage of the fact that you can use the file server built into Server 2012, and you could attach some locally attached storage. Heck, throw in a couple SSDs, okay? $1,000 buy 3 or 4 SSDs. You've got a ridiculously fast, again, for a test lab environment that you're talking about, and a very low cost, and all of a sudden now you've got high performance and you've got, you know, a low cost solution there. If you're running 2008 R2, we actually have the iSCSI server is a free download.
Good. Yeah, it's a free download on downloads.microsoft.com.
Yes. So if you haven't upgraded to 2012 yet, by the way, do that. But if you haven't and you're using 2008 R2, you can download the iSCSI target software as well and make that happen. So a bunch of different options there as well.
Thanks.
When it comes to virtual adapters, and what I mean by virtual adapters, I mean adapters within the VM. We have Virtual IDE, we have Virtual SCSI, and we now have Virtual Fibre Channel. And also we have different types of virtual disks. So let's hop on over there and get to that. So again, I'm going to go back to the Hyper-V Manager. And in fact, you know what? Let's just create a brand new virtual machine from scratch. Let's call this Test VM. So by default, it's going to ask me, where do you want to store the virtual machines? And in fact, a very common question is, Jeff, why do you guys choose the defaults you do? We put our defaults in these locations that people think are a little odd. They're like these public locations in terms of the server. Well, we don't expect you to keep these. In fact, what I expect you to do is, if you have a disk dedicated to storage, or if you're putting these on shared storage, what I expect you're going to do is you're going to go here into the Hyper-V settings, and you're going to set shared storage on some other volume. So for example, you can see here, I've got my virtual disks. They don't actually not on the boot volume. They're on a different volume altogether. They're on V virtual hard disks, and this was on V virtual machines. Why did I choose it? Well, I chose V because it's virtual, and I just put them there because that's where I'm putting all my virtual machines. So yes, this is where you change the defaults, and so from here on out, whenever I create a new virtual machine, it doesn't put them in C:\\, etc. It's putting them, guess what, into that V virtual machines. So I'm going to call this a new VM, test VM. Click Next. Now it's going to ask me how much memory do I want to assign to this virtual machine, and you can see we've got dynamic memory. So I'm going to use that. And from a startup memory, generally what I like to do is I like to give it a startup value of 1 GB. Most operating systems are pretty happy with 1 GB. Then I'll later go in and change the minimum to 512, which gives me the ability to actually reclaim pages later, but I'll get to that in a minute. I'm going to click on Next. And now it asks me for the networking. So what network am I going to attach it to? Well, right now I only have one network attached. This is my general corp net. So this is attached to my physical network. Now we're creating a virtual disk. You'll notice that in Server 2012, we default to the new VHDX format. And I'll talk a lot more about VHDX. But here's something you want to notice. Notice the maximum. That's not a typo. I've actually had a couple people email me and said, that seems like it's wrong. Shouldn't that be gigabytes? No, that is actually terabytes. One of the biggest changes we made in Server 2012 was I talked about massive scale across the board, whether it was procs, whether it was memory, whether it was network I/O. Well, storage got a big bump as well. We now support up to 64 terabytes per virtual disk. Per virtual disk. That's not per VM, because actually we support multiple SCSI controllers, and in fact we support up to 255 virtual disks per VM. So that's actually per disk. By default, we stick with 127, but we could go with 64 terabytes. If you had an existing disk, I could attach that, or I could decide to attach one later, maybe one from a template. I'm going to create the virtual disk now. I'm going to click Next. Now it's going to ask me, how do you want to install the operating system? So if I choose to install the OS later, it'll allow me to continue right along. If I wanted to boot from a CD/DVD, very kind of old school, this machine doesn't have a CD/DVD, so it's actually grayed out. In my case, I'd like to do it from an ISO file. So I'm going to go over here, and I'm going to select Windows Server 2012. There's my ISO file. If I wanted to go really old school and I want to install some really, Paleolithic, Jurassic era operating system, and I needed to do it from boot floppies, yeah, I could do that as well. Or if I wanted to do a Pixie boot. So if I wanted to install from a Pixie server that's doing remote installs over the network, I would select here. So why do we have these different options? Well, here's an important reason why. This actually determines how we boot up the VM. If I still choose to install from an ISO or a DVD, it'll make sure that it'll select the boot order to boot from the CD/DVD. If I choose to boot from a floppy disk, it'll change the boot order to start with the floppy disk. If I do a network-based installation, it'll do two things. It'll set it to boot from the network, over the network, but it'll also create a virtual machine that has the legacy Pixie emulated NIC in there, and it'll set that as the boot device. So that's what's actually going on here behind the covers. Now, by default, I like to go with ISOs or use them from a template from DMM. From this time, though, I'm actually going to go with a standard old ISO. I'm going to click on Next. Here's my summary. This is the name of the VM. Here's how much memory. Here's what the disk is. By default, it's using a virtual hard disk, the new VHDX format, and it's dynamically expanding. And it's going to boot from this ISO file. I'm going to click on Next. So now let's go into that virtual machine, and let's click on Settings. So I'd like to actually give this a couple more processors. Let's make this, let's make it a 6-core. Let's make it an 8-core virtual prox. And in fact, I gave it the IDE controller. But you know what? This is going to be a SQL workload. So you know what I'm going to do? I'm going to create an additional disk. And let's actually walk through the process of doing that. So what I'm going to do is, this is going to be SQL. So my IDE controller will be my OS volume. This will be my boot volume. And this is going to be my data volume. This is where I'm going to put all of my SQL data. Well, I'm going to put it on the virtual SCSI controller. And so what I'm going to do is I need to create a new virtual disk. So we click on New Virtual Disk, and it's going to walk me through a wizard to do that. I could create, you'll notice I have both options. I have both the VHD option and the VHDX option. I've been asked many times, Jeff, you have this new VHDX thing. Does that mean you don't support VHD? What's the deal with the two options? Well, VHD is still around. We have it there on the off chance that you want to create a virtual machine and use on an older version of Hyper-V. It's still supported and will support VHD, but by default, everyone, it's VHDX from here on out. The advantages across the board for VHDX are numerous, which I'll go into, which is why we go with VHDX. In fact, the only reason why you would want to use VHD at this point is if you wanted to go with an older version of Hyper-V. If you plan on using 2012, from here on out, VHDX is absolutely the way you want to go. So now I'm given a number of different options. I can use a fixed size disk, I can use a dynamically expanding disk, or a differencing disk. By default, a dynamically expanding disk is a thinly provisioned disk. So when I create this, it'll probably start out as a couple megabytes, and as I install the operating system, it'll continue to grow and grow and grow based on the actual utilization in the operating system. If I choose a fixed disk, it'll basically say, okay, what's the size of the disk? You want this to be a 32 gigabyte disk? Then it'll actually create a single 32 gigabyte file. So what are the advantages and disadvantages of using one versus the other? Well, generally, dynamically expanding is going to be the way you're going to want to go. And there's going to be a lot of people who go, hold it. Isn't there a performance overhead? Well, we've made some huge performance enhancements with dynamically expanding virtual hard disks in 2012. And in fact, because of that, I have no compunction telling anyone, no problem telling anyone that use dynamically expanding by default. If you absolutely need to squeeze every single last byte, okay, fine, go with fixed. But understand the difference. Here's why dynamically expanding is better. Number one, it's most storage efficient. So if you've got a disk and I install an OS and it grows to 10 gigabytes, and I install SQL and it grows to 12 gigabytes, or install an application and goes up to 20 gigabytes, great. That's what it's actually using. And I can live migrate around, copy it around, move it, and I'm only copying around 20 gigabytes. Even though the entire disk may be 127 gigabytes, it's only grown to 20. If I create a fixed disk and I say, you know what, I want this to be a 127 gigabyte disk, even though it's only using 20 gigabytes, it's created a 127 gigabyte file. So now I've got to copy that 127 gigabyte file around, which may or may not be an issue for you. If it's all located on shared storage and you think it's never going to move, or you've got really high speed storage on the back end, maybe that's not a problem. But a lot of people do like the fact that dynamically expanding or thinly provisioned and only actually allocate when it's needed. And again, I'll show you some of the benchmarks from the performance improvements in dynamic expanding, but that's why this is the default. Differencing disks are something that's been around for a long time, and yet a lot of people don't realize it's there. Differencing disks, you can think of these as linked disks or linked clones. What this allows you to do is to chain virtual disks. So for example, I could have a master disk that has Windows Server 2012 and it's a sysprepped virtual disk. And I want to create a bunch of chains that actually chain off of that master disk. You can do that. You've actually been able to do that since day one. This is a feature that Hyper-V's had all the way going back to Server 2008. But we made some dramatic performance improvements as well with differencing disks in 2012. Differencing disks are a great feature for things like test dev, where you want to be able to take snapshots, different points in time going forward, revert back and forth. They can also be great if you're in a VDI type of environment where you're basically going to be creating stateless types of virtual machines, where you're going to automatically reset VMs back to another point in time. The underlying technology that's been using are differencing and snapshots. So getting back to where we are, I'm going to create a dynamically expanding virtual hard disk. Again, this is the default. I'm going to click on next. It's going to say where do you want to put it. I'm just going to call this SQL data disk. Click next. Now it's going to ask me how big do you want it to be. You know what? I want this to be 64 terabytes, which is, oh my goodness, what's the number? Well, here's how to remember that. The maximum is 65536. 65536. That's 64 terabytes. So if you're interested in that, you can do that. In addition, if you have a physical disk that you would actually like to convert into a virtual disk, not a lot of people realize this feature has been around as well. So I've got a couple of physical disks here. If I wanted to say, you know what, I want to take that physical disk and I want you to basically do a P to V, it's essentially image it into a virtual disk, I could do that as well. I'm going to go with a new blank virtual disk, click next. And that's it, folks. I've just created a virtual hard disk. This is a VHDX format that's dynamically expanding. And just like that, I've clicked on that. So I'm going to click Apply, and my virtual disk is done. If you'd like to inspect this disk, I'm going to click on Inspect, and guess what? It's going to tell me, you know what? Yeah, the maximum size of this virtual disk is 64 terabytes, but right now it's blank. I haven't put anything on it yet. It's taking up 20 megabytes, and that's for for basically allocation tables and things like that, but right now it's using 20 megabytes. And so as I add data to it, it'll grow as needed. And you can see it's VHDX, it's dynamically expanding, and that's where it's located. So let's click on that, and you can see there's my test VM. One of the other questions we get asked all the time is, so Jeff, what if I want to take that disk and I want to convert it? So go over here to Edit Disk, click on Next, and I can now browse which disk. So the one I just created was this SQL data disk. Click on Open and click on Next. So you can see I have a couple of different options. What if I'd like to compact this disk? So say I added a whole bunch of files to it, and I deleted it or I zeroed it, and I wanted to compact and make it in smaller after I deleted a whole bunch of files, I could do that. What if I'd like to convert it to a VHD file? So I created this as a VHDX file, and I realized, oh, I'd like to make this a VHD. Can I do that? Well, actually, it's not going to let me. And the reason why is because I created a 64 terabyte virtual VHDX. VHD, which we still support, but that's limited old school. That only will support disks up to 2,040 gigabytes, a hair under 2 terabytes. So if you want a disk that you want to be able to convert, remember, VHDX is the one that gives you all the way up to 64 terabytes. So in this case, I can't do a conversion. So just to let you know that that's option there. But what if I wanted to convert it from dynamically expanding to fixed? So someone says, you know what, I did dynamically expanding, and in retrospect, you know what, I really would like this to be fixed. I can do that as well. Now I'm not going to do that right now because I don't have 64 terabytes of storage, and if I did, that would be a pretty massive expansion. So I'm not going to do that right now, but that's how you can do some editing when it comes to virtual disks. So I'm going to go back into the VM settings. And one other question I get asked all the time about is, Jeff, I've got this VM running here, which happens to be running Windows Server 2012. This is the final RTM version. And Jeff, you know what, I have this VM running, and I installed it, and I realized, you know what, I wanted to add a data disk. Well, no problem. Let's go ahead and add the virtual disk. And I'm going to do just like I did before. I'm going to give it a random name, click next, click finish. And so now I've just added the virtual disk, and I've hot added the virtual disk to while the VM is running. So now I can click OK. I can go into the VM, and you go here to File Explorer and go, great, where is it? Well, it's not there. You have to go into Computer Management, and you need to go and bring that disk online. So I'm going to go over here into Tools. I'm going to go in here into Computer Management, and here I can find that disk that I just hot added into Hyper-V, and there it is right there. And so now I can bring it online. I can initialize it. I can create a new simple volume. There's my 127 gigabyte. I'm going to give it drive letter Z so we can easily identify it. Do a quick format. Call this data volume. Click next, click finish. So what did I do? Through the Hyper-V UI, I went in, I created a new virtual disk, I hot added it to the VM, I then went into the virtual machine where the disk was, I brought it online, it asked me to format it. Oh, I made it read-only.
Well, in the meantime, while we fix that, let me jump in here and ask a question.
Actually, there it is. Sorry. Actually, it already did it. I think I may have actually tried to format it twice. There's my disk right there. There's my data volume hot added to server 2012.
So let's say I have a virtual machine and it starts to run out of disk space. Now, one of the options you've just showed here is we can hot add a new disk and start storing it in another way. What type of alerts or what type of notifications will we see if we have a dynamically expanding disk and it's reaching capacity on that volume, physical capacity on that one?
This is something we've known about for a long time. One of the things you have to consider when you're using dynamically expanding, and forget about virtual disks, this actually happens on thinly provisioned physical disks as well, is that there is something you have to do, which is you have to manage that storage. Because while you're doing thinly provisioned storage, you're basically telling the operating system, yeah, you have nearly unlimited storage, while on the back end you're really lying and you know how much storage is available. We know this, and in fact we have a number of different alerts that are fired through the event monitor. I believe we have alerts at 2 gigabytes, maybe it's 1 gigabyte and even less than that fire through the event viewer to let you know, hey, you're running low on virtual storage, make sure that you're backing this, make sure that you're taking steps to provide adequate storage on the back end. Of course, really, if you're doing this in a larger environment, you're going to be using something like System Center and Operations Manager, which will have management alerts like that already built and baked into the management pack, and those will get fired up and appear in Operations Manager. But that's something you need to think about and consider when you're using any type of thinly provisioned storage. And it's one of the reasons we also tell people, have told people in the past, why we've always influenced people to use fixed disks. Because one of the nice things about fixed disks is this isn't going to happen. When you create a fixed disk, it's going to allocate that storage up front. You're not going to run into a case where, hey, I created a fixed disk and all of a sudden I'm out of storage later. When you create that fixed disk, it's pre-allocating the storage up front, so you're not going to run into a case where all of a sudden you're out of it, as opposed to a thinly provisioned storage. So a couple of things, hot add, and we'll come back here for some more virtual storage in just a moment. So I talked about the different disk types. We talked about hot add, remove. Snapshots are a key capability in Server 2012. We've had for a very long time, but one thing that we've added new is that you can actually do hot merging of snapshots. So I showed you hot add, remove virtual disks. We can also merge disks. So if you're using snapshots in the past, in 2008 and 2008 R2, if you wanted to merge snapshots, you actually had to bring the VM down so that the merge could happen. This is now all async. This all happens in the background. This all happens live. You can merge snapshots without any impact there. So another thing to bring up are some of the changes that are happening in the storage industry that honestly you may or may not have heard about, and one of those is the big shift to 4K disks. And honestly, I think this is an area we could probably, as an industry, do a better job kind of educating on what's actually happening as we move to 4K disks. Here's what I mean. If you look at disks over the last couple decades, we've been using 512 byte sector disks. Well, storage manufacturers are giving these hugely capacious drives now. We're getting massive capacity, 2, 3, 4 terabyte disks, and they're only continuing to grow. Well, for them to deliver those disks, 512 bytes just doesn't make sense anymore. They need to be able to provide larger sector size to do that. So one of the things that the storage industry has been doing has been transitioning us up from 512 byte sector disks to 4K sector. Now, what they've been doing is they've been doing this in a transition method. So today, if you go out and buy a new disk and you buy, say, a 3 terabyte or 4 terabyte disk, you'll probably see on the side of the box or somewhere on the disk it says it's a 512E drive. So what does that mean? Well, what it means is it's actually a 4K disk, at least on the back side. But on the front side, and what I mean by that is the controller pretends to be a 512-byte disk, when in reality on the back end it's really a 4K disk. The reason why it's doing that is because pretty much no operating systems out there understand 4K disk. If I take a 4K disk right now and drop it into a machine and try and install, Windows Server 2008 R2, Windows 7, it has no idea, it won't even see the disk. That's true of Linux distros as well. They simply don't even know what this disk is. They don't even see it. Server 2012 as well as Windows 8 are the first OSs to natively support 4K. So the reason why this is important is because if we're using this 512E mode, which we've had to use in the past as we've transitioned, there's been a performance penalty associated with that. And so we want to move to native 4K to give us the best performance and scale. So we now have large sector support for the virtual disks themselves. So not only does Windows Server support native disks, but our virtual disks support these new native 4K disks. And so we now have 4K logically sectored VHDXs, so you get no performance penalty. Something very important as you think about as your next storage purchase, major storage purchase happens, very good chance that you're using 4K or that it's coming very, very soon. Another key thing is helping you really take best advantage of your storage. This is probably one of the biggest hidden gems in Server 2012 when it comes to storage that nobody knows about. And I say hidden because honestly it's kind of down there when it comes to low-level features. You probably have never seen us talk about this in a keynote or in a large venue. This is actually a killer feature. Unmap, trim and unmap. So let me explain this. Here, very, very easy demonstration. Think about this. You've created a virtual machine. That virtual machine has allocated, it's using a 60 gigabyte dynamically expanding disk. Within that virtual disk, you delete 20 gigabytes. Okay? Well, what happens today? Today, nothing happens. The underlying storage still sees that you have a 60 gigabyte file. Even though you deleted 20 gigabytes right out of the middle, it still sees there's a 60 gigabyte file. Your underlying storage, whether it's thinly provisioned, it has no idea, doesn't do anything with it. So you actually have potentially 20 gigabytes of storage that you could be using somewhere else more efficiently. Wouldn't it be great if somehow you could notify your storage that all of this was unmapped and readily available for other use? That's exactly what we delivered in the Server 2012. Server 2012 introduces trim and unmap. So let's go back to that same example. I'm running Server 2012 in a VM. It's created a 60 gigabyte file. I now go delete 20 gigabytes right out of the middle. Guess what happens now? With Hyper-V, we notify the underlying file system, which notifies the underlying storage layer that guess what? There's 20 gigabytes, all yours. It's free now. What we're doing is we're actually shrinking the virtual machine, recovering that, reclaiming that, without any user intervention. Think about that for a second. Think about how much money you have invested in your storage area networks, your essentially attached storage that is probably locked inside your virtual disk because this storage never gets reclaimed because this underlying storage array never is notified. So Unmap informs storage of the unused space. It allows the reuse of unused blocks, and the efficiencies at the physical layer is that the VM's unmap is passed to hardware. No other virtualization platform has this capability. It's something we spent a lot of time working very closely to make sure, because the efficiencies and the way to drive down your cost of storage is something you told us and an area we very much focused on. It's supported on VHDX and pass-through disks, so another reason to use VHDX, and it's supported on Virtual SCSI, Virtual Fibre Channel. It's actually supported on IDE as well, but the key thing is it's VHDX. So don't forget about trim and unmap. So VHDX, the new default format for virtual disks, up to 64 terabytes per virtual disk. Enhanced resiliency. So we've done a whole bunch of things to help protect the metadata around the virtual disk to help against corrupting virtual disks. We've done the alignment with the 4K align story to give us great performance and great scale. Enhanced performance, I'll show you that in a second, and the ability to embed custom metadata. So one thing people would ask us would say is, look, I created a virtual disk, and it would be great if on the virtual disk I could, write in some notes like this thing was created on this day with this OS by X and by this person, and be able to embed that into the actual virtual disk itself. So we created custom and you're able to now embed custom metadata in the VHDX itself. Again, these are new VHDX capabilities. So I've mentioned performance a couple times. Let me show you just what the performance looks like. So one of the biggest challenges is to be able to provide, the biggest one, the most difficult one is random writes. Okay. Yeah, sequential reads, sequential writes, yeah, those are nice, but random writes are the most difficult one. Well, let me show you what we've done here. If you look at the left-hand side, that's pass-through, okay? That's a physical disk being passed through into the virtual machine. The other guys call it raw disk mapping, raw device mode, whatever. We've had the same thing for a long time called pass-through. I'll come back to pass-through in a second. There's fixed. Look at fixed. Both VHD and VHDX, we provide you, that's right folks, native disk performance into the VM. Fantastic. Look at what we did with Dynamic though. This is why we're now default to VHDX and dynamically expanding virtual disks in Server 2012. We did a whole bunch of work, performance tuning, optimization in the storage stack, improving the performance that, guess what? Now we're pretty much on par with fixed. When it comes to differencing disks, we also did some enhancements there and drove up the performance there as well. Generally, again, differencing disks aren't something you're going to use a lot in production, but for test dev, it's going to give you a nice performance boost. But look at what we've done here. Fixed is a no-brainer. We give you native performance. Dynamic is pretty much giving you native performance. So let's go back to pass-through for a second. I get asked about pass-through quite a bit. And the reason why, I think, is because the other guys generally tend to recommend using pass-through for their virtual machines. Let me be very clear about something. Hyper-V has never really had those limitations. Okay? We actually recommend using virtual disks because pass-through, honestly, at this point, I don't know of any case where pass-through actually gives you an advantage. Because think about it now. With using a virtual disk, it's completely encapsulated. By using a virtual disk, it's in a single file. By using a virtual disk, we can do all sorts of things such as trim and unmap. We can use things like our disaster recovery capabilities like Hyper-V Replica to replicate those virtual machines. Honestly, pass-through, the only reason why we really had pass-through around in the past was really for one case. It was the fact that someone had a SAN array, they had Fibre Channel, and they wanted to be able to map a Fibre Channel LUN into a VM. Well, you don't need that anymore because we've got virtual Fibre Channel, which I'll get to in a moment. So, pass-through disk, here's the thing to remember. Honestly, stick with virtual disks. Yeah, you can use it if it makes you feel good inside, but honestly, there are very few reasons anymore to actually even consider using it. I wouldn't even recommend it. I'd stick with fixed and dynamic for my virtual disk deployments. Let's get to VHD sequential writes. You can see here we've also done massive performance improvements here to show you. I just wanted to show you what it looked like also on sequential writes as well. I showed you the hard one before, but here's also VHDX doing some great performance improvements for dynamic and differencing. What are the results of all this work? Well, I can pretty much sum it right here. Over 1 million IOPS from a single virtual machine.
And correct me if I'm wrong, we did this on stage at a major event, right?
We've actually done this on stage multiple times in front of multiple thousands of people. This is, honestly, I've had people just, their jaws drop when they see this because think about this. Even a few years ago, to get 1 million IOPS, you needed a cluster of servers. Okay, you needed a cluster of servers to make this happen. We're now delivering this from a single virtual machine. And now with the work we've done with CPU, performance scaling almost perfectly linearly, the memory enhancements to give us all the way to 1 terabyte of memory. Now you couple that with the work we've done in storage and networking, and we can virtualize over 99% of the world's SQL Server. So we actually did a great job in Server 2008 R2, 250,000 IOPS, but now we're doing 1 million plus. And I'll be honest with you, I haven't even found a workload in Microsoft that even approaches 1 million IOPS. I found a couple that do push 250,000. I may have found one that pushes over 400,000. Million IOPS? No, haven't found one yet. So very confident we can virtualize any workload you're looking for, as long as you provide us the adequate storage on the back end. So what does this look like on the back end? What does our storage story look like in Server 2012? Pretty awesome, in fact. Live storage migration, you can do it with no limits. You can live migrate as many as you'd like. You can put VMs now on file storage with SMB3. You can use guest Fibre Channel. The new virtual disk format supports up to 64 terabytes. Guest clustering via iSCSI or now via Fibre Channel. 4K disk support, live VHD merge, live new parent, and something I'm going to get to very soon here, offloaded data transfer. So let's talk about some storage options. In fact, I've actually shown you a bunch of these things already through the UI and created those virtual machines. So I'm going to go ahead and skip ahead. And one of the things I want to jump to is Virtual Fibre Channel. So Virtual Fibre Channel is actually a very, this is a feature that people are absolutely loving. And again, this goes back to the fact that people wanted to virtualize everything, including those workloads that have Fibre Channel adapters plugged into their SAN arrays. Well, you can now do that with Server 2012. With Virtual Fibre Channel, we can create Virtual Fibre Channel adapters in the VM that actually are talking. This is actual real honest-to-goodness Fibre Channel. This is not emulated Fibre Channel. This isn't some sort of faked-out Fibre Channel. This is real honest-to-goodness the Fibre Channel that goes into the VM. What this means is no compromises. You want to run your high-performance workloads. You want to run guest clustering. You want to do MPIO using Virtual Fibre Channel. It all just works. So what do you need? The key thing you need is NPIV. If you bought a Fibre Channel adapter in the last few years, it's most likely there. NPIV has actually been around for a long time. You'll even find it way back on the 1 and 2 gigabit Fibre Channel adapters. The thing to understand, though, is, and this is probably the most important thing, is you have to make sure that you've got a Fibre Channel adapter that's Server 2012 certified. Okay? Here's the reason why. We had to make a couple to support this. We had to actually add a couple of new APIs for the Fibre Channel adapters to support Virtual Fibre Channel. So they have to expose that in their driver. So you may have a Fibre Channel adapter that even says it supports NPIV with Server 2008 R2, but if it doesn't have a Server 2012 driver, it's not exposed to Hyper-V to take advantage of. So if you're thinking about Virtual Fibre Channel, if you're considering it, make sure you talk to your Fibre Channel vendor. Make sure that it's got drivers for 2012. Even go take a look at the Windows Server catalog. But what's great is it literally is Fibre Channel in your VM. And so you can now do guest clustering, MPIO. If you want to run DSM software like EMC PowerPath or other DSM software from other vendors, it just works in Hyper-V and it works flawlessly. Also, live migration just works. So before I show you how live migration works with Virtual Fibre Channel, let me switch on back to Fibre Channel from the VM perspective so you can see what that looks like. So going back to the VM we had before, the one we created over here, Test VM, I'm going to go back into the VM settings, and you'll see here under Add Hardware, there's a new option. It's called Fibre Channel Adapter. So what I'm going to do is I'm going to go ahead and I'm going to add a Fibre Channel adapter into the VM. And what you can do is you would plug this into a virtual SAN, which I haven't created yet. But what you can see here is you've got your virtual Fibre Channel addresses. You've got your worldwide node name and your worldwide port name. Now, for you guys out there that have done provisioning of Fibre Channel, this should look very, very familiar to you, because this is exactly how you do provisioning of Fibre Channel on physical machines. I want to be very clear about this. Provisioning of virtual Fibre Channel is exactly the same thing. Okay? You have worldwide node names and you have worldwide port names. Now, the one question I get all the time is, well, hold it, Jeff, you have two sets. Why do you have an address set A and an address set B? That seems a little, I've never seen something like that before. Here's why. Let's go back to live migration in Virtual Fibre Channel. So, as I mentioned earlier, one of our key core tenets that you told us was that every new feature has to work with live migration. SRIOV was a real trick. Fibre Channel is another one. Because if you do it wrong, you can actually create and expose security holes in your infrastructure. What you really want to do is you want to make sure that virtual fiber channel, like I just mentioned a second ago, is provisioned exactly the same way you would on a physical machine, which is you give a VM a worldwide node name and a worldwide port name. The last thing you want to do, for example, is have to expose an entire host or an entire set of hosts just so you can live migrate around. You're basically opening yourself up to potential security vulnerabilities by opening up the door that wide. I mean, think about fiber channel best practices. Why do you do worldwide node names and port names in the first place? It's so that you can provide very limited, very specific access to a specific server node to a specific fiber channel LUN. Okay, so we've done the same exact thing here. So with Server 2012 and Virtual Fiber Channel, the reason why we have two sets here is because what happens is when we set up Fiber Channel and live migration, when the VM is running, it's going to use one set of worldwide node names and worldwide port names. Okay, but when I live migrate it, it's going to switch and use the second set of worldwide node names and port names. So what you're essentially doing is you're provisioning a VM with two sets of worldwide node names and port names. And the reason why you're doing this is because when a VM is live migrated from a source to the target, there's going to be a point where you have to be able to transition that access, and you want to do it without breaking access to the storage. If it's using only one worldwide node name and worldwide port name, you're going to lose connectivity and you're not going to get live migration. You're going to get this huge drop, and you're going to have the fiber channel has to reconnect itself, and you're going to have some downtime. You guys do not want downtime. You want seamless live migration, which is exactly what we've delivered here with Virtual Fiber Channel Live Migration. So again, that's a key capability built in. So we create a temporary VM on the destination server. We connect the temporary VM's host bus adapters to the fiber channel fabric using the worldwide port name B set. We verify the temporary VM has connectivity to the shared storage. Keep in mind when we do live migration, we always make sure, we always verify that we have access to all of the resources. We won't even perform a live migration if we're not sure we can do it safely in this situation. Then we actually perform the live migration, and lo and behold, we move it from one location to another. Once the VM's been live migrated to the new target, then we delete it on the source. So again, your live migration is always a safe operation. Couple of tips around Fiber Channel. For the guest operating system, it requires Server 2008 and later for the guest operating system. Doesn't work on Server 2003 or anything previous, nor will it ever. Okay, that's a completely different driver model, and we're not going there. You're going to want Server 2008 and later for the guest OS. When you're deploying Virtual Fiber Channel, make sure you have the latest drivers and firmware for the fiber channel adapters. There was a lot of work that we did with the fiber channel vendors, and a number of them performed some updates to their drivers as well as their firmware. In fact, you should assume that the drivers in box have probably already been updated by the vendor, so make sure you do that. The important thing to understand is that you verify that MPIV is enabled on the fiber channel adapter and that it's enabled on the fiber channel switch port. Okay? Two very crucial things here. MPIV is the key way that we provide virtual fiber channel from the physical fiber channel HBA into the VM. Now I want to be very clear, it's not NPV. Unfortunately, there's another option in fiber channel world called NPV. Hyper-V doesn't use NPV. We don't care about NPV. It's not required. It's NPIV. But it's got to be enabled in the fiber channel adapter, and then it also has to be enabled on the switch port. If you don't enable it on the switch port, you'll actually see an error in Hyper-V when you try and go deploy Virtual Fiber Channel. It says it doesn't appear that the fiber channel fabric is supported, it has NPIV enabled. And that means you've got to go check the switch port. So again, check you got the latest drivers. Make sure you've got the latest firmware. Make sure that you've got NPIV enabled on the fiber channel adapter and that you've got it enabled on the switch port. All right. MPIO. So MPIO is definitely something you're going to want to consider. And like I just mentioned in fiber channel, you can use it guest side, but certainly you're going to want to consider it host side as well. So as you deploy a private cloud, resiliency and redundancy are the name of the game. And you want to look at the entire stack. It's not just clustering. It's storage, it's networking, it's the entire stack from the bare metal all the way up. MPIO, or MultiPath I/O, allows us to basically do aggregation and provide resiliency and redundancy at the storage layer. And it can be used for iSCSI, and it can be used for Fibre Channel, it can be used for SAS, it can be used for FCOE. Highly recommended. And it's a key capability that's been built in Windows Server now for many, many releases. I can't even remember when it was introduced. Offloaded data transfer. This is a big one. So here's something to remember. Here's something. If you own a SAN, Server 2012 is simply a no-brainer. Full stop. If you own a SAN, Server 2012 is a no-brainer, and this is one of the biggest reasons why. Offloaded data transfer. So let me explain to you the importance of offloaded data transfer and what this means to you. Offloaded data transfer is really about Windows Server leveraging the key capabilities built into your storage. So for example, say for example I wanted to copy 10 terabytes of storage from one part of my storage array to another part of my storage array. Today, the way Windows Server does it is it would actually read it from the storage array and read from the source and write to the destination to move 10 terabytes. 10 terabytes can take a long time. It can take hours or even days depending on how fast your storage is. But what's happening is the server is doing all of the reading and writing. There's a whole bunch of CPU utilization. We're doing a whole bunch of I/O over the storage fabric. It works, it's great, it'll happen, but it'll take some time. With offloaded data transfer, we are now taking advantage of the key capabilities built into your underlying storage fabric. With Server 2012 now, it's changed. With Server 2012, if I want to copy 10 terabytes, I go to the underlying storage array and I say, storage array, hey, do you support offloaded data transfer? The storage array comes back and says, well, yes, I do. Fantastic. Here's a secure token. Please perform that 10 terabyte copy. Now what's happening now is the storage array is actually moving at 10 terabytes. The server isn't doing the read and writes. Server is getting the notifications, yeah, it's 25% of the way through. It's 50% of the way through. It's 100% oh, all done. But with offloaded data transfer, it's actually performing the copy itself. And in fact, in many cases, it may not even need to move 10 terabytes. It could literally be moving pointers on the array. So all of a sudden, something that could take literally hours or even days can be done in minutes or even seconds. It is huge. What's important about this is it's built right in. It's plumbed right into Server 2012. If you're just doing a file copy, Server 2012 will take advantage of offloaded data transfer. If you're using Hyper-V, we use it throughout Hyper-V. If you're using it for live storage migration, if you're using it for virtual disks, Hyper-V will take full advantage of it. So ODX is a key capability. And the reason why I always bring up ODX is because people hear about this and go, oh my gosh, this is awesome. Where's the on switch? How do I make sure that this thing is enabled? Well, the important thing to understand is there's nothing to enable. We automatically negotiate this with your SAN. If your SAN supports it, we'll take advantage of ODX. By the way, this is also included in the Windows Server 2012 file server. So if you're using the file server and we can use ODX, we will take advantage of it as well. But keep in mind that this is something that has to be enabled in your storage. Your storage has to support ODX. Now the good news is we've been working with storage vendors since very, very early on. So if you go to your storage vendor, and you can assume we've talked to all of the storage vendors out there, they've been working like mad, and if it's not already there, they're going to support ODX very soon. Here's the important thing for you to understand. If you're going to go buy some new storage today, make sure it's got offloaded data transfer. If someone comes to you and says, hey, I want to sell you new storage, and it doesn't have offloaded data transfer, the answer is, okay, show me the stuff that's got ODX, because honestly, the benefits are just tremendous. Don't even look at something that doesn't have offloaded data transfer. And so it's an industry standard spec. We took it to all the storage vendors and they've been implementing it. And most of them, from what I understand, it looks like it's a free firmware update. So if you own a SAN array already, contact your storage vendor and see if they've got ODX support already waiting for you. And here's just one more example. I asked the storage team, I said, look, how long would it take you, to create a fixed disk on an ODX system versus a non-ODX system? So they actually said, oh yeah, creating a 10 gigabyte fixed disk on a standard desktop, laptop, basically it's a single file, it's 10 gigabytes, and then we zero it out for security reasons. It takes about 3 minutes. I said, well, how long does this take on an ODX system? They said, well, here we could show you, but don't blink or you may miss it. We literally clicked return and it's done, less than half a second. So that's just one example. But like I said, we use it throughout all of Windows Server, and Hyper-V uses it everywhere. So, all right, so I've been talking about storage with block. I've been talking about Fibre Channel. I've been talking about SAN. Now let's talk about some of the major changes we've made in the Windows file server and spaces. So when it came to Server 2012, we looked at virtualization very holistically. We didn't just look at VMs. We certainly could have, but that's kind of a two-dimensional representation of the world. We want to look at everything. We want to look at networking. We want to look at storage. And in fact, one of the things we wanted to provide was storage virtualization in the box, because we wanted, again, to help reduce the cost, make it easier to manage, and provide great high-performance solutions using the Windows Server 2012 file server. So one of the things that this foundation is built on is storage spaces. Storage spaces is storage virtualization. This allows you to take a whole bunch of JBODs, or just a bunch of disks, and with spaces, you can basically pool these and then create these spaces on top, these virtual LUNs, these virtual disks. It could be a simple space, it could be a mirrored space, it could be parity space, and then you can do things like thin provisioning, things like this. What this allows you to do is, again, to take just a bunch of disks. Could be SAS. You can buy some low-cost SAS and plug these into a server using spaces, and then pool these, and then distribute these out, and carve these out, and distribute it to your LUNs. Of course, if you want to make this a great solution for clustering, you can cluster support spaces. So you can use cluster shared volumes, which Simon's going to talk about, which basically allows us to create simple and mirrored cluster shared volumes atop a mirrored space, and where you get a CSV common namespace across multiple nodes in a storage space. So think about this as providing the underlying storage virtualization for pooling and amassing all of the disks. Now, if we take that as the base backend, what do I need to do to make the front end to create a shared storage infrastructure? That's where the Server 2012 file server comes in. And first thing I want to tell you, if you've ever set up a file server, whether it's Server 2003, 2008, 2008 R2, take everything you know and literally throw it out the window. 2012 is a completely new and different beast. In fact, if there's anything, I kind of wish we would have renamed it, called it anything else other than Server 2012 file server, because everyone seemed to think, oh, it's probably the same thing. This is a completely different beast. Server 2012 file server is dramatically improved across the board. So for example, now we can provide continuously available file servers. I can have a 2-node file server, yank out the power cable on file server 1, and file server 2 continues right along. We have resiliency, redundancy, we've got protocol enhancements across the board. It's a major, major release. So what is file storage for virtualization? Well, now you can store your Hyper-V, virtual disks, your config files, everything on a file server with SMB and Server 2012. You can use spaces, you can use shared storage as the underlying way to virtualize the disks below it, but then file server presents the shared storage on top of that. So how do we handle continuous availability? So if I'm going to put all of my critical infrastructure on a file server, how do we do that? Well, there's a couple of things we need to be able to handle, such as intermittent network failure. So what happens if I've got a host that's talking to a file server and all of a sudden, whoops, I'm temporarily disconnected? No problem. We have resilient connection handles that are reestablished. The application doesn't even receive an I/O error. This is all handled transparently, all this resiliency built into the SMB3 protocol and the enhancements we made into Server 2012 file server. Well, what if I want to do a scale-out design? I want to take advantage of multi-channel. So I talked about MPIO for Fibre Channel on iSCSI. Well, guess what? We've delivered that with SMB3 and the file server in Server 2012 with multi-channel. With multi-channel, we transparently use an alternate network path. So for example, you've got normal operation, but guess what? Maybe there's a disconnect. Well, that's okay. We continue right along using the other path. And when the other path comes back along, we can handle failover, we can do aggregation, and again, the application hums right along. This can be your SQL Server data, this can be your Hyper-V VMs, all of this running transparently, giving resiliency. What about continuous availability? So what happens, for example, if I've got a file server and that file server just, like I said, somebody yanks out the power cable. So I've got a Hyper-V host accessing a file server on node A, and I yank out the power cable. Well, guess what? The failure of the file server, the share is moved over to the new node. This is, again, all happened transparently. Connections are reestablished. The application does not receive an I/O error. So I mentioned continuous availability. That's a big difference between high availability. With continuous availability here, the application isn't even notified. This is transparent failure so that your applications like Hyper-V and SQL can take full advantage of that. So how do we handle a Hyper-V node failure? What if, for example, someone's in the closet and yanks out the power cable of a Hyper-V server? Well, that's no problem. We take advantage of cluster client failover. This is, again, some fantastic work we've done between the clustering team and the file server team to make sure in the case of a Hyper-V host failure, the VM starts on a different Hyper-V node and the state handles are created very quickly without delay. So we've very much thought about what are the resiliency, what are the redundancy options on both the file server side, on the storage side, whether it's the spaces, whether it's the file server itself, whether it's multiple file servers, whether it's Hyper-V hosts. Finally, one last thing I want to mention is host backup and restore. We've made some huge changes with how this works now. So if you're using backup on a file server, well, guess what? We've got VSS now, virtual shadow copy, virtual shadow services for SMB now. So if you want to take snapshots and your snapshots are running on a file server, we've created a VSS provider for SMB. So again, tremendous amount of work here to make sure that file servers in Server 2012 give you a first-class, fantastic performance with Hyper-V. So again, we've run through a bunch of these different things. Last thing I've got to point out, I know we're way over on time, but trust me, there's so much rich goodness here. I cannot miss this one, deduplication. Here's something that I think has floored a lot of people. So like I said before, Server 2012 file server, this is not your grandfather's file server. This thing is a fire-breathing dragon, okay? Continuously available, scale out, resiliency, multi-channel. Well, guess what? It also includes deduplication. So if you think about why you generally buy some large, SAN devices, for example, or storage appliances out there, very often deduplication is used as a method to basically help you reduce your costs for storage. Well, we include deduplication now as simply a checkbox you enable in the file server. It's great for a virtual disk library. You can store more data in less space. And basically think about it. You got a whole bunch of VHDs on a VM library. You want to be able to use it on a greatly reduced disk footprint. In fact, let me give you a perfect example. One of the things that I mentioned previously was we do Microsoft Management Summit. We do MMS. And we do all of that virtualized. Well, I've been working very closely for many years now with the team that delivers those hands-on labs. They do a fantastic job. And one of the things they do is they literally have, many terabytes of disks that's actually being used to deliver all these hands-on labs. And so what we have here, actually this is gigabytes. I'm sorry, this is a different library I'm thinking of. But basically, before disk duplication, we had a Hyper-V library that was using 62 gigabytes of storage. Okay, we then turned on deduplication on the same exact location, and guess what? After deduplication, it was only using 1.39 gigabytes, over 60 gigabytes of savings. Who wouldn't like to save 60 gigabytes of savings on their storage just by checking a checkbox? So deduplication, a key capability in the new Windows Server 2012 file server. So, number of takeaways. Again, when you think about picking your disk type, think about how it's going to be used. There's not one size fits all answer. I know lots of people come in and say the answer to everything is SAN. Well, it could be, depending on what the workload is, what the environment is. Or maybe some direct attached storage, maybe the file server. Really comes down to understanding the workloads, understanding the IOPS, and making sure that your storage can deliver those IOPS. Clustering requires the using of shared storage, but it can now be a SAN or it can be a file server. So that's a big change. And what's nice about that is it gives you the ability to use a SAN if you'd like. You can also use the iSCSI target as a free solution, or if you'd like to use the file server. And then finally, don't forget about MPIO, which can be used as for additional resiliency. And it can be used host side, and it also can be used guest side. So that's it for this session. We know we went a lot into storage, and we went way over time, and we'll be back for the next one.
Sounds good. And so we're going to take a lunch break now, and we will be back at the top of the hour. Please also check out the new poll questions that we've added. And as always, feel free to ask your questions and comments. We have a few new MVPs that have recently joined us. So Cedric Bravo and Robert Smith have been great answering questions. So please continue to ask all these questions, and we'll see you back at the top of the hour. Thank you.